Uh, Hello. This is Group 5 final project for Fundamental Data Analytics. So for our business and data understanding, wait, my name is Rana Saputra Liancha. Mas apa? Ini di sini soalnya.
My name is Fatih Filbert Farudin.
And my name is Muhammad Gavino Rahmadi.
So for the business and data understanding part, the business problem that we chose was that as environmental impact and favorable policies increases demand for electric vehicles, manufacturers need to find ways to make EVs more practical, such as through extending the range. One of the main reasons that consumers hold back from buying EVs are due to range concerns in comparison to normal internal combustion vehicles. So identifying correlations between key factors to ranges can help EV manufacturers to create longer range vehicles. So for the business objectives, is one to identify key factors or characteristics in vehicles that might affect the range and prediction. So from data analysis, be able to predict an EV's range based on technical factors or characteristics. And then the analytical task is the regression problem, predict continuous target variable range to driving distance on a full charge. And the requirement is descriptive features, battery capacity, energy consumption, rotational power, top speed, acceleration, car type, drivetrain, efficiency, and charging speed. The target variable is the range. The data source is the Kaggle dataset, and the data volume is 478 unique electric vehicle models from various brands and origins. So for the project management, in terms of cost benefit, the Kaggle dataset provides a free resource of information to make a model from which would create value and savings for research and development, as EV manufacturers can focus resources on researching the specific technical features that will improve range and cut costs on other more relevant features. So the data needs cleaning, exploratory analysis before a model can be made. And for the project plan, for the first and second weeks, will be used for data acquisition. Third and fourth can be used for exploratory data analysis, and 5, 6 can be used for model training, and 7, 8 can be used for model evaluation and deployment. So that's for the business and data understanding for our progress on the IPYNB file. So from the data understanding, the dataset has 10,038 data entries in the dataset, has 478 rows of data, and it's divided into 22 columns. 13 of them are numeric, which are the top speed, the battery capacity, torque, efficiency per kilometer, range, acceleration, fast charging power, towing capacity, seats, length, width, height, and cargo volume. Then for the categorical columns, brand, model, battery type, drivetrain, fast charging port, car body type, segment, and the source URL. So for the null values, there are 202 in the number of cells column, 26 in the towing capacity column, 7 null in torque, 1 in model, 1 in fast charging power, 1 in fast charge port, and 1 in cargo volume. So here's the distribution for each: top speed, torque, battery capacity, efficiency, range, fast charging power, acceleration, towing capacity. It's the same. Okay. Yep.
Okay. Next, here is the data understanding scatter plot. You can see the top speed versus range, and then the battery capacity and versus range. Next. And here is the categorical first numeric. In the left side, there is brain versus range, and in the right side, there is car body type versus range. Mm. Okay, from data understanding, positive predictor of range is battery capacity, and then top speed, then fast charging power, torque, width, and length. Like dropping the number of cells column because 202 out of 400 of 8 null, and then for cargo fall from category to number 8 dataset, normally assign it as categorical. Then categorical null in model change with unknown in fast charge port using the mode. Numerical null change with medium. Then next. And here's the data preparation outlier. You can see by yourself the code and the output. Next. Where is for binning? Binning the battery size, acceleration and range. The small battery capacity from 0 to 60 kilowatt, and the medium one is 60 up to 80, and this one, the large one, is from 80 up to 200. For the acceleration is the performance normal and slow. Acceleration time is from 0 to 5 seconds. Then normal is 5 to 8 seconds. And then the less is slow 8 to 30 seconds. For the range is low, medium, and high. Next. And here is the encoding part. We use one hot encoding to all categorical feature by clicking a list called normal underscore call with brand, model, battery type, fast charge port, drivetrain, segment, and carburetor. Next. Next section.
So for I'll be continuing with the data preparation and coding. So we're going to use ordinal encoding for the previous three binning that we did for battery capacity, acceleration, and range normally. And nominal underscore calls is filled with so battery size bin from small, medium, range, a large, then performance underscore bin, slow, normal, and then performance, range bin, low, medium, high. So that's the code for that.
Close.
So next is the feature selection. So for the feature selection, the target column is a column for the model relation is the range. Pearson correlation is done across column with range. So it's actually the battery capacity most positively correlated and battery size being most negatively correlated. It's is the table generated by the collab. Then we will conduct ANOVA test to calculate the F score and p value for the feature against the target, which measures the linear independence. So higher F scores and lower F scores indicate a statistically different and stronger linear relationship. So we find MI value because the MI score measures how much the value of a feature reduce the uncertainty about the value of the target. Useful to find feature that might not be linear correlated but still informative. So this is the result of the feature selection. We are actually using the filter because for our context, it's actually the best method compared to wrapper and the other one because call for the wrapper this is for the wrapper. This is the result of the wrapper. As we can see, the the variables selected by the wrapper they are actually they it's not for our it's not okay for our model because actually
The wrapper
the
selected models of
numbers of cars.
not the columns itself. So it's not fit for our models.
So and we're going to use we also use the embedded through let's find numbers of features, but although it's actually very similar with our filter method, but it generates too much variables, so it will slow down the model at the end of if it's generated. So I think that's all from us. Uh,
Okay.
Thank you so much, Miss, for
Thank you much for listening.
listening.